we are doing a collaboration with CSIR and IFET College so that we will be knowing more about 3D printing. Okay, so what we are going to learn today is that these two topics we will be learning about the basics of 3D printing. Okay, how 3D printing works, and I will be showing you the FDM 3D printing process, the complete process we are going to discuss about that today. Okay, I will be showing you like why we are using this technique and what are the printer parts, because I have a printer with me right now, and using that printer I will be also demonstrating or like showing you how to give a print command, right? We will be discussing all of them. So let's begin talking about myself. I think sir has already told I am right now associated with 3D education. So basically my target is I teach or deliver sessions to school students, the college level. So basically our aim is to provide 3D printing education at the grassroots level, right? We basically, our 3D company has an aim that we provide the grassroots level training to not only school students but also college students and all. So even from the last 2 to 3 years, we have been doing this FTP sessions, that is faculty development programs and STTP programs. Okay, so basically a lot of like engineering students, they are not familiar with this technology. So what we do, we like go to the, we used to go before this corona pandemic, we used to go to the colleges and show them the 3D printer and how it is working. We used to have the demonstration of the software and all. Okay, so right now we are actually doing that through the online mode. So basically we will be looking into the software part also, like designing the printer specific software is there. We will be looking into that also. All right, now to moving forward, let's talk about 3D printing. Now, as the name is actually suggesting, 3D printing is all about manufacturing something layer by layer, right? It's like you are creating a three-dimensional object directly, and the process is like we are adding the material layer by layer. Okay, we will look into that how it is being working. We will be having a live demonstration. So see, now one thing I want to tell you about is today we will be seeing a thermoplastic being 3D printed. So one doubt, everybody gets the doubt like, can only plastic be 3D printed? No, the answer is like a lot of uh, a huge range is there where the materials are wide. Like even metals can be 3D printed, ceramics are 3D printed, right? A lot of polymers are 3D printed. Even see the most number of patents that are being registered in the 3D printing field, they come from the medical department, right? Right now, the development is such that a Israel-based company, they are trying to 3D print a hut, right? A small hut. They have tried to 3D print that. It is of that of a frog, and it just worked for around 1 or 2 seconds, right? They are trying to inculcate that. Okay, so see the level of 3D printing it has reached, right? Now, right now, if you're talking purely on engineering basis, even architecturally, if you talk about a lot of companies in India, specifically like L&T, has used this tech 3D printing mechanism to, they are trying to build houses. Okay, real size, like lifelike sized houses, they are trying to build through this 3D printing technique. All right, so this is the reason why this 3D printing is actually a part of Industry 4.0 revolution. Right now, a few terminologies that are like synonyms of 3D printing is rapid prototyping. Why it is called rapid prototyping? Because see, prototype is the first product that actually has been made, okay, for display purpose or just showcase purpose, right? Now, if you want to create a prototype, we can easily get this the prototype through 3D printing. Like what happens is, now going by the older methods, what happened is if we go to the casting method, so even if for creating a prototype, we have to make the mold, okay, and using the mold we can create the prototype. So it takes a lot of time, right? So if the prototype is not selected or there are some changes that is required to be made, So the mold has become the a waste. Now in 3D printing there is no mold actually required, and directly we are creating the final object. Okay, now uh, let's talk about this flow chart over here. So basically the process, actually what is happening in 3D printing is, the first thing is we take any CAD software. Okay, you must be have heard about Mr. AutoCAD, SolidWorks. Okay, there are some high level, or KTR, there are some high end software. Basically they are used in the industrial level to create uh, what you say CAD models. So what is happening is, today I will not be using those high-end softwares, but I will be showing you a very basic software, which is like we use this software to teach to schools, colleges. Why? The reason being, see, any person can learn this software, that is SketchUp. The reason being, the tools are very simple. Okay, we do not go into very details, and simply directly you can create a 3D model. Okay, but if you want to learn more about CAD designing, I would suggest you to use high-end software such like SolidWorks. Okay, CATIA, they are high-end CAD modeling softwares, and they are like more helpful for as a mechanical engineers, right? Now going to next stage, what we do from digital model, we will be selecting the material what is required. We will be using the 3D printer, and the final object is created. Now let me talk about the difference. Okay, the main difference you can see over here is, I want you to observe this picture for a few seconds. Now in the top, what is happening is, you can see we have got a huge block over here. Now from that block, we are cutting out the materials and getting the final product. Okay. From the bigger block, we are removing material and getting the final product. But in additive manufacturing, what is happening? We are not removing, but we are adding the material layer by layer and getting the final product. Now, if you compare these two images, you can see that the material wastage coming out of this subtractive manufacturing, it is actually very high. All right, but the wastage that is coming out from additive manufacturing, it is a lot less as compared to subtractive. Okay, that is a huge benefit over here. Now in the screen, I have two images in front of you. All right, now see, in the left hand side, I have a very complex object over here. All right, now this complex object, it cannot be one second please. Okay, so this complex object, it cannot be 3D like made through subtractive manufacturing or the traditional method of manufacturing, but this is actually possible through 3D printing. So one advantage over here is of 3D printing is that complex objects can be created. All right, very complex objects, they can be created through 3D printing. Now to the right, you can see over here, this is a bracket over here. So you can see a reduced size has been made. Okay, like you can see the material utilized for this product, it has reduced a lot. All right, now what is happening is, this process is called topological optimization. So basically wherever the stress is present, we are keeping the material there, and wherever the stress is absent or the material is not required, we are actually removing those parts. Okay, so basically you can see, using the topological optimization method, what is happening is, we are reducing the amount of material required to make a product, right? So in that case, see, the final product that you are able to see here, this can be produced only by 3D printing. So in those areas like 3D printing can actually, there it is helping the aeronautical and the rocket industry to make lighter parts. Okay, you can see the weight will be hugely reduced because the material has been removed over here, right? So this is the advantage over here. We can get a lighter uh, strength. The strength wise, we can select which is the best object. Okay, we can 3D print them so that we get the optimum result. Now talking about that, I will be going into the 3D printing technique that we are going to discuss today. we will be going through the process of 3D printing, the complete process that is involved. We will be looking into that. So before that, I had just told you about the layer by layer process. Now see, a lot of process are there about 3D printing, which follows the same process, that is layer by layer deposition. But today the material we are going to use is thermoplastic. Okay, we will be going to look into thermoplastic. Now, the method is called FDM, fused deposition modeling. Okay, fused deposition modeling. Now, the process is very simple. What we do is we have a wire. Okay, the wire is known as filament. Okay, the raw material is in the form of wire. Now, it is going inside a heater. All right, so basically, the heater will be present at the melting temperature. So the wire or the raw material will melt at the nozzle. You can see the moving part, the lowermost portion, that is the nozzle part. So basically that is the part which heats up, and inside this the melting takes place. So after that what actually happens is we have an arrangement to move that part. All right, we have an arrangement that will actually move the part. Now see, it is very simple. Imagine that we apply mehendi to our hands. What happens is we have a mehendi cone. So if we squeeze the mehendi from the cone, from the pot top, we are squeezing it out. What happens is it is coming out in like a small liquid or material. Now the motion we are giving it through the hand. Okay, the motion we are providing through the hand. And the same way, what is happening is from the nozzle, liquid material is coming out. It is like we are providing it continuously. We are feeding the material, and at the same time we are moving the nozzle, right? So all these things is both of them are like happening together. So we will look into the process how the machine is like moving according to the design, right? You can see some design. You can see in the image over here a bolt is being printed here. You can see it is moving according to the design. So how does the machine know how to move accordingly? So that is why we are going to look into. See, so this mechanism you can see over here. We have a hot end part over here. Okay, the raw material is coming in the form of a filament. This is a wire. Okay, it will melt over this part. This is the nozzle part. Okay, we called it the extruder part. I will be showing you in the printer what the extruder actually is. All right, so basically the extruder is the one which is pushing the filament into the hot end. All right, see, as I told you, the material has to come out continuously, so something is actually pushing the material, right? So that part is known as extruder. Okay, now after that we have the mechanism, x-axis mechanism, y-axis movement mechanism. Okay, so we have a z-axis mechanism. All right, now what is happening is after one layer has been deposited, the bed plate or the build plate will come down. Okay, after one layer is deposited, the bed plate will come down, and on that another layer is printed. So this is how one layer upon another layer the printing is actually taking place. Okay, so now the main reason I would say why we are using this FDM method is that it is the cheapest form of 3D printing. Okay, as compared to many other methods which are available, this is the cheapest method of 3D printing. Now one more thing is FDM is not the first 3D printing technology that was invented. So there is another method, is stereolithography. All right, that was the different. The mechanism is completely different over in stereolithography. So in the year I think around 2012, this was made popular. The reason being a lot of free open source work was done. After that, this FDM technology was like available to a lot of people, and they started making their own 3D printers. Okay, that was I think from the company in UK. So after that, a lot of companies started manufacturing these products, these 3D printers now. So the thermoplastic is like the two, three varieties available. We can get a good quality surface finish over in the thermoplastic range. Now, whatever we do, FDM or in the 3D printed products, what you see, there will be lines. You can see it is printing layer by layer, but the lines are actually visible. Okay, through the naked eyes, even you can know about the lines. Now, if you want to avoid the lines, you need a better 3D printing technique. I told you about stereolithography. So in stereolithography, the procedure is completely different. The raw material is completely different. So in that case, more complex 3D printed products can be made. Okay, so let's look into the 3D printing technique that I am going to show today. So basically what it actually covers up is, okay, this is the complete 3D printing process. So what I will do is, see, I will be using a CAD software to design something. Okay, I will be using a CAD software to design something. I will be trying to create a keychain today. Okay, so basically after doing that, I will like transport it to STL format. Okay, this I will also try to say why we do that. Okay, and like after transferring to the STL format, I will transfer this STL file into a like slicing software. Okay, the software that I'm going to use today is for designing. I'm going to use SketchUp, and for slicing I'm going to use Cura. Okay, now this Cura software, what it will do, it will create a G code for the 3D printer. All right, now in the printer I will show you how the printing is done, then we will get the final 3D printed object. Okay, now let's go to the first thing, that is the designing part. Okay, so let's minimize the screen. I have already opened up the SketchUp over here. So I think it is visible to everyone. Now see, it is a very simple software. What is actually happening here is, you can see three lines over here. We have a green line, red line, and a blue line. So basically these are the axes, the axis, x-axis, y-axis, and z-axis. Now, why I am talking about this as a very simple software, because now see, to create something in this, anything solid, what I will do, there are some 2D tools over here. I take up a simple rectangle tool. I am just creating a rectangle. There is a 3D conversion tool. We call it the push pull tool. I click on it. I am very simply, without any effort, I have created a 3D object. All right, without going into higher details like the dimensions and all, without doing anything, I simply created a 3D object. So see, whenever I take up sessions, not only take up about students of schools, colleges, but also see, in the medical sector also we have to teach them about designing and all right. So this software is very basic, and actually this software is used in the architectural field. All right, so basically in the architectural field they use this software to create buildings, outlines of building, and all. But as it is a very simple usage for like college students, school students, we actually use it in our sessions. Now let me open a new tab. Okay, now let's do one thing. I'm going to create a keychain over here. All right, now looking into this tools over here. So simply there are tools like rectangle tool is available. Okay, let me do 100 comma 50. I give some dimension over here. Okay, now let's zoom it out. Now you can see this is a flat surface. Now you can see that it's completely paper like. Now a 2D image like this cannot be 3D printed. It should actually have some uh, thickness and all. The first thing that I will be actually doing is giving it some thickness. Okay, I'm giving 3 mm thickness. Let me do it 5 mm thickness. Okay, you can see this thickness is 5 mm that I have given. All right, now after that what I will do is, let's do some settings over here. Let's create a outline. Let's create some sketches over here. All right. Now see, let me type some. Okay, college IEFT. Let's type it in capital and let me place it over here. So basically, what is happening is I can resize the model. So this can be actually done in any CAD software because in engineering colleges you will be having access to them. So as this is a very simple topic, like simple software, I can actually use it to teach not only school students, even those students who are not from engineering background. Okay, so we use this software in that case. Now see, once it is done, you can see it's okay. Now one more thing that I will do is I will be putting some additional design factors over here. All right.
Sir, sir, small, hello, sir. Anand, sir.
Hello.
Anand, sir.
Yes, sir. Yes, sir. Please go ahead.
A small obligation. IFTT, I think, is best.
1 second. Okay. 1 second. Correct. Yes. Okay. Let's make some changes. IFET.
Yes. Thank you.
Okay. Thank you, sir. See, any designing changes we want to make, we can do it over here. The better thing is after 3D printing, if anything happens, we will again have to come to the drawing board to make some changes, right? So this is the advantage of using the CAD CAM softwares. All right. All right. Let's make it in this direction also. Okay. So right now I have with me a 3D model. Okay, the complete 3D model is present. We have a base, and on the base we have some letters over here. Now what I will do is, okay, let me do some spot software specific changes over here. Okay, now see, I have a completely 3D model. Now the next step, see, the first step as I had discussed was to design something. What I have done is I have designed a CAD model. Now the second step is I have to save this file as an STL format. All right, let me go over here, file. Okay, if I go to normal save option, so see, like we save a Microsoft Word document, it will be saved as .doc. Okay, Excel, if you are saving Excel as XLS. Now every software has a different format. I mean, SolidWorks, it is, if you are saving a part file, it is SLDPRT. Now if you are saving a SketchUp file, its extension will be .skp. But what we need is in 3D printing, we always save as one format, that is STL. Okay, you see it is written over here, export STL. Now STL stands for standard triangulation language or standard tessellation language. Now see, let me press this button. Okay, it is asking me to save somewhere. I am going to save it in the desktop. IFET. Okay, now one thing I want to say over here is, see why we are saving it as STL format. So what is actually saved in this STL format? See, what is happening is all the surface points you can see in a 3D object. So basically the surface has a lot of points. Okay, so only the complete surface data is saved in the form of triangles. Okay, so in the form of triangles, the surface data, like the location of the points, okay, where each point is present. So basically that data is present in the form of triangles. Okay, so let me minimize the complete thing. Okay, see, this is the STL format. Let me right click on it and let's go to properties. See, it is stereolithography mesh. Right. So after this, the STL has been created. What we will do, we will be going to a slicing software, that is Cura, C-U-R-A, Cura. Now, let's do one thing. I am going to show you a few settings. Now, before going into Cura, I want to say you a few more things, like a printer, okay, a 3D printer, what you can actually going to see today. What happens is it has some physical dimension and all. Okay, the first thing is the bed plate, the maximum print volume and all. So in the screen you can see I have kept the design machine DB plus. So basically I have put the settings according to the 3D printer. See, in the market there will be different variety of 3D printers. Okay, so in this software what we do, we put the settings of the printer like which we are using. Okay, right now you can see in the settings you can see the x-axis, y-axis and the z-axis data we are providing it. Okay, we are doing it manually, right? So if I would have used a different 3D printer, I would have given different setting. All right, so now you can see the x, y and the z. So this is the dimension of my printer, the maximum size that my printer can print. All right, so this data I have to give to this software. Okay, so like this software will like convert the STL format, my designing CAD file, into a G code. All right, that is the work of this software. See, so for creating a G code, it is using some data. I am providing like physical dimension and all, I am providing it to this software. Now this software is like creating a G code. So what is G code? So G code is like a geometric code. So basically, as I told you, there is a nozzle. The nozzle is like pushing the material out, and it is falling down, and the movement is according to some code, right? So the movement of the hot end and the different motors and that is present in the 3D printer, so they are controlled by the G code. All right, that G code is actually created by this software. All right, so you can see I have put that the dimensions over here. I have a heated bed over here. All right, a few more settings like I will be telling about the what the nozzle is. Okay, what the material diameter is over here. Okay, so we will look into the physical part. Okay, once I've given some settings in the printer, okay, I will be getting this print volume. It is a 200 cross 200 cross 200 box over here. So it is a complete print volume that is that we are going to use to print. Okay, in the lowermost you can see a checkbox is over here. A lot of checkboxes, grid like structure is there. So Betty, that is the build plate. All right, now let me do one thing. Let me like minimize the screen. Simply what I will do, I will drag this STL file. Okay, I have simply dragged the STL file into this. Okay, now before going into the setting part, I will be like, let me zooming it over here. Okay, yes, you can see the yellow part. Yes, one thing that I want to tell you. So this is yellow in color. This doesn't mean that it is going to be printed in yellow. So the material color that we are going to use in the 3D printer, like if I'm using white color, it will be printed in white in color. If I'm going to use yellow color, it will be printed yellow. So the reason why it is yellow, because it is printable. Now suppose if the size of the object, see, I can also increase or decrease the size. If it is 300%, I'm increasing the size to huge extent. You see, I have created a very large object and it is not fitting the box. Okay, it is not fixing the print volume. So that is the reason why it is gray. That means it is not able to print that. But if it is the actual size, it is printable, right? Now what I will be doing is, after this I will be applying the option over here, slice. Okay, now listen carefully. What actually happens is, I have got a model, I have got a CAD model. So now what happens is, in this software what we do, we convert the complete model into individual slices, right? We convert the complete model into individual slices. All right. Now what will happen is, like, each layer will be made. It must have already, see, the slicing is done. Let's go and view the slices. I have gone into preview mode. Okay. Now, okay. All right. So this is the preview mode. Now you can see is, let me close the settings over here. Okay. Now you can see there is a slider over here. It is showing 35 layers will be used to print the complete object. That means this complete object will be 3D printed in 35 layers. Okay. So now if I'm dragging it, you can see a few more things over here. Okay, it is printing from the bottom. You can see the first layer is completely 100% is it is filled up. So let me zoom in and drag it to the center of the screen. Okay, the first layer is completely filled up, and gradually if you are printing more and more, you can see the structure is like it is in a grid structure. Okay, it is not completely filled up. A grid like structure is being printed, and the flat surface that was there, the base, it was again completely filled up, and then the letters we have, it is left out. The grid is continuing till the final layer. Okay, so see what we have an option over here. We can put the infill as different. Let me zoom in over here. So basically this part, it is known as fill density or the infill percentage over here. Okay, of any object, this is the inner part, and this outer part, it is known as the wall. Okay, this outer, like, the green and red line, if you can see, these are the walls, and the inner part, the yellow part, they are the infill. Okay, we have the option to decide the infill, the wall thickness and all in a 3D printing mechanism. Now in subtractive machine, like a CNC machine or milling process, you can see we are not able to fix the density of the material that is made. Okay, but in 3D printing we can decide the density of the filling that we require. Okay, now you can see all the layers are 3D printed one by one. So let's see what all settings that I have applied. Okay, let's go to the prepare option. See, in the preview mode only, I want to show you each individual layers. Okay, each individual layers actually has some thickness. Okay, each individual layers, they have some thickness. Okay, now that here thickness is called layer height. Okay, so that is called layer height. Each individual layer has some thickness, that is known as layer height. Okay, now you can see the data over here is 0.3. The layer height data is I have shown here is 0.3. So basically, the nozzle, it is dependent upon the nozzle, right? Nozzle means the part from where the material is coming out. There is a hole present in the nozzle. So basically, the size of the nozzle, it is the whole diameter is not nozzle diameter. The nozzle that is mostly put, or like default size is 0.4. So this data layer height should be always less than that. All right, so it is like 0.3 means very thick layers are printed, and the time is 1 hour 15 minutes. All right, so now see, one more thing I can do is, if I want to print the product in very thin layers, now what will happen is the surface quality will be very high, because as the number of layers becomes more, okay, there will be a effect of like the surface quality will become very better. As you can see, if the layer is thick, I am able to see the layer properly. If I'm reducing the size of the layer, the surface quality will increase, because the more number of layers come up. Now one more thing I need you to observe is, if the layer height is 0.3, suppose it is 1 hour and 15 minutes, I change this to 0.1. Okay, I will be getting very small slices over here. There were 35 slices at that time. Now if you observe, the number of slices is like 102. Okay, time is very high. That is, if you want a very good quality print, the surface quality, if you want more, the time will be increased. 3 hours and 30 minutes will be required for printing. Are you getting my point? So you can see the gram weight of the object is 22 gram. So what I do, I will be like I require like um, a good quality also, but the time also I want to adjust. So I keep it at 0.2. Okay. So if I print at 0.2, the time will be in between, okay, 0.3 and 0.2. Great. So now next thing is, we saw, yes, let me keep it in this side. See, we look into the layer now. Let's look into the walls and the top and bottom. Now see, there are two things. One is the wall. So now you can see this green and red line. So basically, it is a cell, just like a tortoise has a cell. It is living inside the cell. Now the top is known as top and bottom thickness, and the sides we call it as wall. Okay, we give the name of the wall thickness right over there. The data we give it, like if I want two walls, it will be like 0.8. Now it is like multiple of the nozzle diameter. Okay, it is that multiple of nozzle diameter. All right, you can see the wall is created. Inside the wall we have some filling. Now what is top? Now let's go to the top. A few more layers up I will go. Okay, see, this is completely filled up. So basically, why are we giving this data like top and bottom thickness? Because this top and bottom, they will be like completely filled up. That is the reason why we are giving this setting. In the middle portion, what is happening? We are keeping some infill density and having a wall thickness. Okay. Now, if you want a very strong product, we will be increasing the wall thickness, and we can also increase the density. All right. So the density, like this is the infill percentage. Okay, you can see the infill density is 20%. If I want, I can make it like let's make it 80%. Okay. Now, if you see, the pattern should be like same, the grid. Okay. Now if you observe, you can see the infill pattern is like, it is more compact. Okay, a lot of material has been used up, a lot of space has been used up. Okay, now if I want a very strong object, I can go for this. If I go for 100%, okay, so every layer is like filled up. Okay, every layer is like filled up from bottom to top. Every layer is like 100% infill. All right. So ordinarily I go for 20%. See, now this is 10%. The amount of material has reduced a lot. Okay. So let's keep it at 20% with the grid structure. Okay. So basically this is the setting we do for infill. All right. Now the next setting we have is that of the material. Now see, there are different thermoplastics available. Now thermoplastics are the one where we heat it once, give it some shape, okay, and once it cool down, we get the final object. We can again reheat it, we can remodel it again, get the another object. Now thermoplastic has that property. Now different thermoplastic raw materials is available. The one that is easily used or easily available is PLA, that is polylactic acid. It has got this condition. the melting temperature is nozzle temperature should be 200 and the bed plate temperature should be 60. Okay, for PLA material, these should be the conditions. Now, if we go for suppose ABS material, acrylonitrile butadiene styrene, so basically the settings are likely different. For that metal ABS, we use 240 nozzle temperature and the bed plate is 90. Okay, so this temperature we will be using according to the material that we have. See, basically in the printer we do not set the temperature and all. Whatever is requirement is done. We put every requirement in this software only. All right. So the next thing is the speed. According to the printer, it has got some standardized value like this printer. While the manufacturer will be actually giving you a range. So which is the best printing speed, which is the optimum printing speed. So accordingly, we put the speed. Okay. So I have put here 60. That is the optimum range. Now, if you print very fast, see, we have to give some time for the layer to cool down, and once it cools down we can put another layer. Now this speed, if it is very high, the cooling may not take place properly and the surface quality or the print quality will be greatly reduced. Okay, so these are the basic settings that is required for printing. All right, now let me do one thing. So after this G code has been made, okay, what we do is we take an SD card. Okay, now if we want, we can connect the printer through a wire to the laptop and put it on print. But the thing is, suppose something happens to the computer, like it turns off or what something happens. So we do not want to take the risk. So we take an SD card. Okay, now I will be copying this file, the G code that is created actually to the SD card. Okay, let's wait for a few seconds. Okay, the SD card has come up. Okay, I've got the option to save to removable drive. Name it separately. Okay, I'm going to save it to the SD card. Now, what I will be doing is I have this. Okay, I have the file in the SD card. All right. Now, let me do one thing. I will be stopping the sharing of my screen. I will be going to like I will be Rahul sir will be turning on his mobile camera.